Hello friends, welcome to my channel. Let's have a look at problem 49, group anagrams. So this is today's daily challenge problem. In this video, we're going to share two treatments. First is in the option 1, we're going to use a vector representation to do this problem. The second option is to do the sort each of the words. So here we can do sort without essentially increase the term complexity is due to the second constraint. So with that said, first I'll read through the statement to digest the problem, and then we look at the treatment and share the code. First, the statement. Given an array of strings called strings, group the anagrams together. We can return the answer in any order. So an anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So here are three examples. So example 2 and example 3 are special cases. In example 1, so it only contains an empty string, and in example 3, it contains only one string, right? So generic case is example 1. So in example 1, so we have a bat, so we have a net and a 10. So there are anagrams to each other. Similarly, 8, eat, tea are anagrams to each one another. So with that said, let's also look at the constraints. So the constraints actually are important for a problem. First, the length of the strings is bounded below by 1 and bounded above by 10 to the power 4. So 10 to the power 4 actually defines the upper bound of the problem size. And each of the phrase or word in the string so is bounded below by 0 and bounded above by 100. So 100 is a constant, right? So if we sort each of the words, so the term complexity is 100 times log 100 up to a constant. So this is again a constant, right? So the third one is that the words in the string consist of lowercase English letters. So that's actually help us to do the first option of solutions. So with that said, so we are ready to look at our treatment. So for the treatment here, so I'm going to share two methods. The first one is option 1. So we're going to use a vector representation. So essentially, this is a character frequency table. So we are going to represent each word by a 26-dimension vector, with component being the frequency of that letter. And the second option is that we sort the word as a word due to the assumption that the word length is bounded above by a constant, the constant 100. So this idea is based on the observation that the sorting results for anagrams are the same, right? So in other words, if two words, so after we sort, they result the same string, so they are anagrams actually. So with that said, we are ready to look at the code. The code actually is very routine or direct, straightforward. First, I'm going to look at option 1. So I'm going to initialize a dictionary. So in this version, I'm going to write with some details so that we can write option 2 with very short code. So now we are going to iterate, right, for word in strings. So I want to get a vector representation of this word, right? So first I'm going to initialize a vector, so it is 26 dimension. And then we're going to represent this word or convert the word into a vector. So we're going to iterate over the characters in the word. For character in word, what we are going to do is that we want to find the corresponding component of the character and then set that to be the frequency after we finish traversing the word. So this can be done like this. So vector, so let's first find the index. So this is ordinary number of the character minus the ordinal number of A, right? A is the beginning word of the lowercase English letter. from A to Z, right? So if the character is A, so this index is corresponding to 0. If the character is B, so this corresponds to 1. If the character is Z, it corresponds to 25, right? So in this case, we're going to increment the corresponding component by 1. So this way, we have this representation of this word currently we are looking at. So we want to store it as a key corresponding to the word. So because a key should be immutable, so but the list is a mutable object, so we can actually introduce a key so to be a tuple of this vector, right? And then what we're going to do is that we check if key in D, right? In other words, this key already appeared, so we can do something like this: the key append the current word. Otherwise, so we're going to set the key equals a single element list, so let's call it word. So this finishes the problem logic. So next we just need to do the return. We return the corresponding values in the dictionary D. So we are going to return, so let me use a list comprehension to conform the problem requirement. So item for item in D values, right? So I guess actually maybe just directly return D values. That should also be work, but that's a dictionary values object. Let's return a list. So that's the first version. We can do a check now. Yeah, it passes the first example. Now let's look at generic case. Yeah, it passes all the generic cases. So this version of solution should help us establish intuition. So next we are going to copy the function signature, and we're going to change this one to be v1. So we want to write a shorter version. So notice that we're going to use sort each of the word, right? So this needs a little bit more operations than traversal, but it's still manipulable. So in this problem, so here I'm going to initialize a result to be the collections. So I'm going to use the default dictionary container. So I'm going to use list as a container, and then so we're going to traverse the word for word in strings. So what I'm going to do is that I'm going to sort it as, so this gives us a list. Then we can use tuple, so that I can use it as a dictionary key. And then what we're going to do is that we can access this key, right? And then because we have a default container that is a list, so we can directly append the current word, right? So this way, as we mentioned above, so in the return we can return D values directly, but here let's return this result values directly. If you like, you can use a list comprehension, but this will be fun. So with that said, let's look at the code here. So answer. So let's see here. So this is the result, right? As sorted the word. Yeah, it passes the first example, I guess, right? So now let's look at the generic case. Yeah, it passes all the generic cases. So I guess that's about it for this problem. So no matter what we use in the format or appearance, like a vector representation, or sort the words and then tuplize it as a key. So essentially, we're counting each of the character in the word and their corresponding frequency. So overall, we are using a character frequency table. So with that said, I guess that's about it for this video. Thank you.